In every firework explosion, there is an oxygen-rich chemical that is our oxidizer and a fuel that is a reducing agent. The combination of these reactants produce heat vital for our explosion. The oxidizer, or oxidizing agent, is needed to burn the mixture inside the firework. The fuel, or reducing agent, is needed to burn the oxygen to produce the energy needed for the explosion. For our oxidizer, typically fireworks use potassium nitrate, potassium perchlorate, or strontium nitrate. For fuel, they use sulfur, charcoal, aluminum powder, or magnesium powder. Here's an example reaction. Potassium nitrate plus sulfur yields potassium oxide plus nitrogen plus sulfur dioxide. Potassium nitrate is one of our common oxidizers, and sulfur is one of our common fuel sources. We can find which atom is our oxidizing and reducing agents by looking at the charges of the reactants compared to the charges of the products. This will tell us which is the oxidizer and which is the reducing agent, even if we have an idea that potassium nitrate is one of our common oxidizers and sulfur is one of our common fuel sources. Below the word equation, you can also see the unbalanced chemical equation. KNO3 plus S yields K2O plus N2 plus SO2. I will use the rules for assigning oxidation numbers to determine the charges of each of the atoms. On the reactant side, potassium has a +1 charge because one of the rules states that the group 1A elements have a charge of +1 and potassium is in group 1A. Nitrogen has a +5 charge because the nitrogen is a part of a nitrate ion, and as one of the rules states, the sum of the oxidation numbers is equal to the charge of the ion, in this case nitrate. A nitrate ion has a -1 charge, so the atom charges in NO3 must add up to -1. The 3 oxygen atoms have a -2 charge, which adds up to -6, so the nitrogen part of this ion has to be a +5 to get a -1 charge. Oxygen has a -2 charge because the rule states that oxidation number of oxygen is always -2 and less than OF2. Sulfur has no charge because the rule states that monatomic elements composed of 1 atom or diatomic elements composed of 2 atoms have a charge of 0. On the product side, potassium has a +1 charge and oxygen has a -2 charge because same rules on the reactant side. And nitrogen has no charge because it's its own monatomic element. Sulfur has a +4 charge because one of the rules states that the oxidation number of it is equal to its charge. So because sulfur is bonded with O2, which has a -4 charge, -2 charge individually, but because it's a diatomic atom, there are 2, so we'll have a total of -4, which means that sulfur must have a +4 charge. The oxygen, a part of sulfur dioxide, has a -2 charge because of the rule that states oxygen has a -2 charge and less than OF2. Now that we have established the charges on the reactant and product side, we can see the changes in charges of each atoms from the reactant side to the product side. Potassium and oxygen stay the same. Potassium stays at a +1 charge and oxygen stays at a -2 charge from the reactant to product side. Thus, there is no change for potassium or oxygen. The nitrogen goes from a +5 charge to a 0 charge. It is gaining electrons, which is classified as reduction. But this means that because it gains electrons, it is taking electrons from another atom or element, which then causes that atom or element to lose their electrons, or oxidize. So, nitrogen is considered the oxidizing agent. The sulfur goes from a 0 charge to a +4 charge from the reactant side to the product side. Sulfur loses electrons, undergoing oxidation, but because it causes another atom or element to gain electrons, it is the reducing agent. So our fireworks oxidizer is nitrogen, which although may not be considered oxygen-rich as an oxidizer, can pull easily from the oxygen charge because of its strong charge and because it wants to become a more stable atom. Our fireworks reducer is sulfur. Our oxidizer nitrogen will produce the oxygen needed to burn the mixture inside of the firework. The reducing agent, or fuel, sulfur, will burn the oxygen to get the energy needed to initiate the reaction.